So we should be live. There's a little delay, and I'm shutting this down. And let me take the link. I'm going to go to Gmail. And I'm going to send the link to myself. Composing a letter. I'm looking for Mike. Okay, let's see. Okay, so this is the Brady broadcast on another computer. Good. Looking really good. All right, I'm shutting this one down. So, let's see here. Let's see. I'm going to test a screen test. Screen test. Trying daily motion here.
Am I muted?
No, I can hear you. Just can't see you. That's all right.
No, I can't hear you. Why can't I hear you? Check my sound.
I can hear you. I'll type in. The
Shit. Okay, try now.
Okay, can you hear me?
Yeah, that's better. Yep. Yeah, what isn't your YouTube page? Oh, there it is. I was looking for your YouTube page.
This isn't like my official channel because I'm having to learn so many things, and I end up just creating these garbage videos that are all my failures in the test. And people that subscribe to my regular channels I don't want them to be getting my garbage as I'm learning stuff.
Okay.
Because I'm trying to learn. I'm trying to decide on a streaming platform.
Yeah,
And
me
I'm probably
too.
gonna learn. Yeah, I'm gonna probably try to learn Streamlabs. That seems to be popular.
Oh,
So,
where the hell's it? Oh, that glare's come from my library. Hang on. This damn camera picks up every light as a glare. It's pretty horrible. So you're streaming. So are you streaming this live right now, or are you recording?
yeah. See, this is what I'm all learning. It's recorded. So watch what you say.
Okay, you're going live.
I'm already live when you entered the studio. Okay, so I just learned something. Okay, so I apologize. That's why. First of all, I wanted to thank you for letting me do this on my channel, because I'm learning how to do all this stuff, and I've been messing up, and just so this is just a chance for me to get some of the bugs ironed out. So don't talk about anything too private right now. We can talk about stuff privately after I figured out how to end the broadcast.
So I was live when I walked in. Basically, do
you want me to end? I mean, I can.
No, that's fine. So because if you ended on StreamYard, I don't think there's any way to get back.
Yeah.
I don't know. I've been complaining to them about some of the problems that they have with their like they should have multiple screen sources and a bunch of other stuff, and they should have that audio button on, because if you share a browser tab, they have it off by default. I think probably for privacy, but I always forget to turn it on, so then I have to stop and go back. And
I'm thinking of going to Streamlabs. So that's what James Modern Day Debate and SFT use, and they're also able to tie it into Patreon. So
really,
yeah,
I'm gonna check that out.
You know, I'm gonna tell you, I'm really going to be focusing more on just pure science education.
Than the fight.
Yeah.
The good fight.
Yeah, I mean I'm professionally a creationist, but really there's just a lot with basic just science that needs to be. Teaching something is a good way to learn it, and
it is.
So that's what I'm headed. Just if you'll forgive me, this is a totally off-topic question before we get to our subject. I do have some relatives that have substance abuse problems, alcohol.
Yeah.
And this hand sanitizer, because they've run out of isopropanol, they have these ethanol ones that are like 72%. And I sprayed it on my, I put it on my hands, and I'm like, oh my goodness, this smells like vodka. And I just like, I'm kind of concerned about some of my relatives. If they have you had people, I mean, I think it's public knowledge because you had your MDD debate about Alcoholics Anonymous. Have you heard from any guys about any problems that's causing them?
No. Washing your mouth out with Listerine, ingesting a little bit of alcohol doesn't trigger the mechanism. You have to at least take in an ounce of alcohol within like an hour before you're going to trigger that whole craving mechanism, to where it sets you up. So like I will use, and a lot of alcoholics don't like this, but I'll use non-alcoholic beers, which have like 0.2% or something like that, and you'd have to drink like 24 of them in an hour in order to get a buzz off them.
Are you fine with that? Drinking, what's the brand?
Heineken now has a zero, which has zero alcohol in it, zero ethanol.
So if we hung out, I could buy you one of those?
Oh yeah, or a Moosey, or there's a couple others that taste pretty good. And when I drank those, I was sober for like, I don't know, 10, 15 years, and I drank non-alcoholic beer, this Moosey. When I started drinking again and I took a sip of beer, I thought, my God, they put solvent in this beer because it tastes horrible. Because you can taste the alcohol, and the alcohol really, I don't think it's a pleasant taste. I don't know.
Well, see, the thing is I like the smell and the taste, but I can't ingest very much without getting sick. So
Yeah.
I'm kind of wired not, that for some people they just have a toxic reaction. I'm one of those, which I guess is kind of a blessing.
Yeah,
But
I'm wired.
I'm kind of concerned about some friends and family that, because when they started putting all this ethanol on the market, it's like that would be like 144 proof.
Yeah, if they drank, I would recommend drinking it.
Yeah.
Yeah.
I mean, it might just trigger. So sorry for the aside. Not
Yeah, but for washing their hands, there's no way that there's going to be enough alcohol ingested in your system to trigger that little brain mechanism that sets in.
Because I was wondering if the smell, because I mean the smell was very fragrant. It was powerful for me. I wanted to go grab a glass of vodka, but I can't drink very much anyway. I mean, I will just get after about like half a shot, I just don't feel good. I mean, I might just taste it, but that's about all I could take because, like I said, I get a toxic reaction. So.
The thing is, if an alcoholic who's sober goes into an environment like a bar, and he feels like he might drink or like it might set off, a problem, then he needs to go to more meetings. Because when you're doing well, I mean, you could have people drinking all around you, and the only thing that bothers you is that you're afraid that you might accidentally pick up a drink. Like somebody brought me, I ordered a Virgin Mary one time. They brought me a Bloody Mary with vodka in it. And I took a sip and I panicked. And I was like, oh my God, I spit it out. But if you're doing well, you have rather than craving, you will be panicked by it, right? I mean, you don't want to drink in any way, ever. When you're actually working a program and you're in recovery and you're well in recovery, you have just the opposite relationship with alcohol. So you wouldn't worry about, Listerine or whatever. I mean, it's not going to affect you. So
yeah, well, thanks for that. Just you had a debate with someone on, is AA a cult? What was your position? It's not, or it is?
Not a cult. Not a cult.
Not a cult. Okay.
No, there's 12 traditions in AA that nobody ever talks about. They have 12 steps, but they have 12 traditions. And the traditions are there so that we never become a cult. There's no leader. There's no organization. Every group is on its own. People vote, as to what they're going to do in the meetings. There's a whole bunch of stuff in there. We never, we're not supposed to publicly, like if I were a celebrity, associating my name with AA was kind of a no-no, that sort of thing. So that, we don't get any celebrity leaders or anything like that. And there's just, the traditions are a wonderful formula for anybody who wants to create a organization that doesn't get off track, with leaders and BS. We don't need that.
Well, I'm sorry. I'm not trying to be rude, but I don't know what it is, but when I have this cigar in my mouth, I just feel de-stressed. I can't actually, that's another thing. I can't actually inhale.
Oh, you can't smoke it?
I can puff on it.
You can puff on it. Well, yeah.
If I try to, that's why another reason I could never really smoke. I mean, I could light up, but I can't inhale.
Right. Okay.
So, but it just, I don't know. See, just having it, I could see, I think there's some people that just kind of need to light up, but they don't really need the nicotine. It just de-stresses them. So it must be something really primitive in the nervous system.
Could be, yeah. So fitness. What the hell is
I'm going to ask your permission here. I don't think we said anything too private, but just could I read some of our email exchange on the fitness?
Oh yeah, yeah. I don't think
Okay. So Mike wrote me at 2:20 p.m. July 6th, Monday. Said, I think we should do a live talk on fitness. I think I can help you get through the thicket you are in and focus on what you actually want to focus on.
Yep, that's fair.
And so I said, man, can't we talk about organic chemistry instead? We were just starting to get along. Now you want to argue.
Mm-hmm.
Okay, how about tomorrow afternoon we talk fitness? I just woke up since I was working outside all at night till 6 a.m. because it's too hot in July to work outside during the day. I had to set up a lot of lights so I could quietly work in the garden and driveway and garage at night. It's in the 90s every day here. At least at night, it's only about 75, but really muggy at 95% humidity. And you responded, you scared to find out why you're wrong? I really want to help you, not argue. And then I wrote, I doubt I'm wrong. Brady's paper confirmed exactly why I've been right about this. PopGen fitness is an empty concept. Brady pointed out the proverb of the bird sitting on a dung pile and its predictive value for whether it's going to rain or not. That's the PopGen definition of fitness in a nutshell. And then you responded, and none of that is why you guys are wrong. And then I said, okay, so do you want to have a public discussion tomorrow? And you said, yes, I do. Pick a time. Early is better. So.
Yeah. And I had another email for you that I think it ended up in the trash bin. I forgot to hit send, but it said basically, you and I, high noon, outside the saloon, fitness.
Oh, yeah. Wait. Let's see.
That was another exchange.
Yeah, that was one of the better ones.
Okay.
And I just missed that one.
Yeah, okay.
That was actually one. Okay, yeah, that was one of the better ones. So, a little history. I had written. So this started, I think, partly way back about 8 weeks ago when Professor Stern Cardinale. I debated Ron Garrett, and I'd meant. That's when the discussion about fitness came on. Professor Stern Cardinale saw a post I made on Our Christianity, highlighting that link, and he complained about my mention of fitness, and I said it's garbage. And he said, "Do you want to hash this out? I'm free next week." And so all this began about 8 weeks ago. And then I had, because this was connected to work I was doing on Fisher's fundamental theorem with Bill Basner and John Sanford in the aftermath of their very successful paper on Fisher's theorem. You may have a different opinion, but it's successful in that it got a lot of attention.
Yeah, right. I have a very different opinion. Yeah. And
so I'm just giving us and maybe our one viewer who filling them in. And so that got the discussion going. And then I and Professor Stern Cardinale had our first discussion. We talked a little bit about fitness, not much. I then got invited to publish a paper by an editor of a small ID-friendly journal. And then I got actually the paper already reviewed twice, and it looks like it's going to be accepted. I've already gotten pretty much a promise from the editor they'll get accepted just as long as I clean it up. But I got some input from faculty who actually do sit on secular peer review committees. So, I mean, they gave me Brady's paper. They said, "Sal, you're really spot on. Here's some more papers." And the Brady one was very impressive. And so that's where I did not come up with the bird on the dung pile thing on my own. I got it from Brady, but I think that was cute. So
yeah, I got the Brady paper here. It's pretty big. I was able to read most of it. I got a little bit irritated with it at some point. He was talking about, is Brady he's the one that was talking about it being tautological? Yeah. that a theory being tautological or circular, which makes absolutely no sense at all. But Brady, 1979, that's the one.
Yeah, Brady, 1979, and this is a very interesting history because Dawkins even mentioned it, and it's mentioned in passing, his work with transform claydism. So I'd known about this whole thing a little bit in reading it both in Dawkins' work and Denton's work, but I didn't make the connection that this is the same guy. So this is a very interesting thing. And then before Michael Behe and the ID movement, it was people like this that were kind of coded by creationists. People that were like Norman Macbeth, who was a Harvard-trained lawyer but wasn't even a biologist. He started some of this criticism.
Right.
And the reason it got a lot of attention was I didn't even know about Macbeth, but a lot of very prominent biologists took Macbeth very seriously. They disagreed with him, but they were very impressed with his scholarship. So this is a very interesting perspective because my understanding is these guys are not creationists.
Could I pause for a second?
Yeah, go ahead.
Yeah, I have to go off.
Sure, go ahead. I'll see if I can pause this. Yeah, go ahead. We have a commercial break here, and maybe to fill a little bit of time, I'm really just trying to learn the StreamYard. So I figured this would be, since it's such an obscure discussion, that this would be a good time to use the Brady Bunch paper. I'll call it the Brady Bunch paper. So since I expect so people would be interested in this discussion to begin with. So sorry, this is a bit of a throwaway, but I'm trying to learn the StreamYard platform. And let me read through the abstract a little bit. This is by Ronald H. Brady, Associate Professor of Philosophy, whose paper is Natural Selection and the Criteria by Which a Theory is Judged. And he said, his abstract says, when recent literature on the falsifiability of natural selection is examined, critics and defenders seem to communicate with each other very poorly. An examination of the structure of tautology and that of causal explanations provides criteria by which to examine the claims of both critics and defenders. So, Mike, I was just filling in the time and just...
Right. So I have a DoorDash delivery, and they decided to replace everything I wanted from a drugstore with everything I didn't want. And then my cats crashed something at the same time. So I'm like, okay, I'm sorry. I'm back.
Now, do you have to feed your raccoons at night, or just do they come visit in the day?
No. There's one of them that'll come early, a smart one, gets up at like 5 p.m. And he gets more of the food than anybody else, so he figured it out. But the other ones come at night. So, and of course, I don't really feed raccoons because we have a city ordinance.
Oh, sorry.
I just made it up. So
sorry.
Okay, so Brady. Well, there's a couple of things here. The first thing I noticed in rewatching one of your videos today, the fundamental theorem of that natural selection. Nobody talks about that. Nobody knows about it. It's only mentioned in tiny little places. Why are you guys so obsessed with it?
There is a mythology around it.
From where? From maybe Dawkins back in 1976.
Dawkins and Fisher himself, and it's been mentioned as anytime you hear something that's called the fundamental theorem of natural selection. So that was a very catchy title.
Oh, it is. Yeah.
And if Fisher said it, if Fisher said it's fundamental, it's like hard to run away from. So there has been 22,000 or so Google star citations. You'll actually see it. Bill Basner found quite a lot of discussion on the theorem, especially by Plutinsky. So it depends on who you talk to, how fundamental it is. However, I'd say the specialists, if we went to Joe Felsenstein, Ewens, Lessard, and any of the top-rate population geneticists today, they'll say it had no role. And I think that's the accurate characterization. Right. But among kind of like those outside of the field, they just had such a great regard for Fisher. Not to mention, Fisher was very central in a lot of ID arguments. So Fisher has kind of this strange position of being, he was a Christian, he was an evolutionist, and his Fisherian statistics played a big role in William Dembski's formulation of intelligent design. So it's kind of one of these odd relationships where he's so it was focused on because his name came up much more so than Sewell Wright. So we think of the three founders of neo-Darwinian theory as JBS Haldane, Sewell Wright, and Ronald Fisher. Ronald Fisher was always like number one in ID literature and creationist literature for a variety of reasons.
You're probably not going to like this, but I like to call that the creationist straw man. That was 90 years ago that that thing came up again. 90 years is quite a bit of time, and a lot has been done since then. But there's a whole bunch of I don't know how to structure this exactly. I guess, what do you think it's for? Dr. Dan, I call him, told you that you were using the wrong definition of fitness, and the only definition of fitness that you can use is that of reproductive rate. So overall, it's a average fitness basically for a population is the only thing you can use in this kind of modeling. Do you understand why he is so adamant about that?
I think I do, because they want to hold to that definition, and they don't
want to. They have to.
Yeah, they want to. They don't want to correct themselves because it's a terrible definition. But if I may back up a little bit, why Fisher? At least when I've been discussing it, I wouldn't say it's fundamental to biology, but it is called the fundamental theorem, but it's also, I focused on it, me personally, I can't speak for others, just so that it's a good illustration of understanding how it's defined in evolutionary biology and population genetics. So all I did then was, it was a good vehicle to say, okay, let's just look at this theorem, and then now we could learn the population genetic definitions. So we have symbols like W, and then S coefficients, and then capital W, which is absolute fitness, little lowercase w, which is relative fitness. And then we have the lowercase p, which is the allele or gene frequency. The more correct term is allele frequency, but gene frequency is embedded.
Yeah.
So I'm not going to speak for other creationists, and I found that I get in trouble when I try to defend what other people say. It's better just let them defend themselves. I focused on the theorem mostly as a teaching vehicle, because as they learn what the theorem actually states, they'll learn population genetics. I wasn't arguing that biology will fall apart if this theorem is proven inadequate. That is not what I was aiming. I was just making fun of the fact also that someone who is esteemed as Richard Dawkins would just make a fool of himself. And he's making basically the same mistake. He said it's biology's central theorem. So it's not like the creationists are alone in saying that. Right. He kind of gave the creationist fodder by calling it the central theorem. So we were taking at least for myself, I'm just taking the opportunity to point out I think he's a buffoon. So,
well, I think what Brady started out with is talking about a tautology, like A equals A. So if you have if a theory is a tautology, I mean, if the most fit organisms survive, and the things that survive are the most fit organisms, okay, that is sort of like duh. I mean, that means it's an absolute fact that that's what happens. I mean, if you're born with a significant number of mutations, you aren't going to live. You're going to die. So I mean, I don't see the problem. But in pop gen, when you start out, what you do, like you start out with a Hardy-Weinberg equilibrium, and for figuring out allele frequency, and you learn a bunch of very, very simple models for doing population genetics. And Fisher-Wright had the simplest model of all, and it was something that you start out with, but nobody thinks that your model is actually going to predict what a population is actually going to do. And that was Brady's criticism, is that it had no predictive power. And that is Felsenstein's and Lewontin's criticism as well, that it's much more complicated than that, especially when you get mating pairs. Because when you have mating pairs, Brady made a case that each individual had its own phenotype, that was very, very unique. But then when you get mating pairs, they may well have different genotypes, and that's why they mate, because they are so different, that sort of thing. So I mean, there's all kinds of complications, and the models have nothing to do with the validity of evolution. I think you guys are wanting something else.
Okay. There is predictive value for you mentioned the Hardy-Weinberg equilibrium.
Yeah.
And there's predictive value for what alleles will end up in a population if you've started out. This has the predictive value of if you have alleles that have more reproductive success than other alleles at the same gene locus, then it'll predict if you can say that the relative reproduction rate, which they call the relative fitness, is constant, which is hard to establish, and Lewontin proved this, but on that assumption, it will make a prediction as to what alleles will end up. We see that in antibiotic resistance. That's very clear. I think what Brady was saying, and this is where it relates to the ID proponents, and especially Michael Behe's analysis of his book Darwin Devolves, it's one question to say if alleles have a certain relative fitness, what alleles will eventually dominate the population. That's actually somewhat straightforward. What is harder to say is whether one creature, like say a Sarcopterygian fish, will evolve into a bird. That's what
you really want to get at. And that's the problem I have with all of this, is that you took a very roundabout route to get to the point where you're really asking the question, can genes evolve? Or can proteins evolve in a positive direction? And that's sort of the primary difference that we have, is that you believe there's a direction in mutation, and I do not. And there can't be, mathematically, there can't be. So using these models, like using anything that Fisher-Wright did, or later Kimura did. I've got the Kimura and Crow here. I've got Kimura's neutral theory right here. I've got Crow and Kimura here. And I looked at the quotes that you had from them. I can't remember where they are exactly, but all these guys, they started modifying.
I think page 270 in the Crow and Kimura.
220 in Brady's paper, or no, in what's his name, Olison. He said 244, but in my book it's actually 224. So you said it was on what page?
I think it's 270.
270.
The bottom. I could be wrong. My memory's
Yeah,
not as good.
there was one place.
Fisher's theorem, and
Well, I
you'll
may
see
have
the
a
derivation for the diploid version.
yeah, I may have a different printing of Fisher's theorem in this one, but he quoted from 224, I think it was, and that was where's 224, and he quoted a note on terminology with use the word fitness as a synonym for selective or reproductive value of a genotype. So basically, but if you're modeling a population, you're trying to figure out what a population does. What Dr. Dan was trying to tell you is the only way you can do that, because we're not interested in what's going to happen to your kids or even your grandkids. We're interested in what's going to happen to a population for a long period of time. So you have a DT, or DXDT, where X would be the population size. You're looking at the incremental change, but you're looking over a long period of time. Okay, so you're not looking at the predicting what's going to happen next week. You're looking at prediction of what's going to happen overall. So that's what you're looking at, which alleles are going to fix in a population. And then, of course, we have genetic drift, which popped up. And I'm not even sure if Fisher was even aware that sort of thing happened back in 1930. But it becomes very complex, and but the models in no way can be used to prove or disprove evolution. And that is not the purpose of modeling. The purpose of modeling is to find out what some specific part of the overall reality is going to do. Like if we're just modeling, hypothetical genes that are beneficial, we're looking at how fast that is going to fix in a population of n size. So that's what we're looking to with modeling. You understand that? I think there was some suggestion that Sanford and who was the other guy?
Bill Basner.
Sanford and Basner's paper. They added epistasis, they added mutation, and they added linkage disequilibrium, I think, to their formula.
No, I don't think those had it, and that probably would, if they had added it, it probably wouldn't have helped Fisher's theorem. That's a known result from Patrick Moran. So they were criticized for not adding it, but I'm like, well, they probably helped Fisher's case by excluding it, because it's a known problem that when you add linkage and epistasis, fitness actually declines. Fitness can decline. There's no guarantee then. It'll make anything of Fisher's theorem even worse. It doesn't guarantee that there'll be decline, but there'll be enough pathological cases that it can't be a universal rule anymore.
Yeah, there you're suggesting that some mathematical model is going to be a problem for evolution. No, it's a problem for the mathematical model, because we know that life is here. I think you froze up on me, Sal. Uh-oh. I froze the creationist. This is good. What just happened? Am I still live?
I reconnected. That is obnoxious. Okay. I don't know. Maybe I'm getting metered by my internet provider. I've been on the net too much. I'm sorry about that.
I think I may have been on the whole time, even though it's your stream. I don't know if it blanked me out too or not. But
so we were talking about the epistasis and linkage, and that's before I got cut. We broke up.
Yeah, well, epistasis is mentioned in the 1983 book by Chimera on neutral theory, and it's in Crow and Chimera. They make a big deal of both. linkage disequilibrium and epistasis, and they work it into their models, and they don't seem to conclude that evolution is wrong or that there's a problem with including these in their models. But everybody's, if the model comes out and says that life isn't here, that we all went extinct, obviously the model is defective, right? Or something is wrong.
I'm trying to process what you're saying, and I think this is valuable because maybe I think first we may not state our position as clearly, or you may think we're saying one thing when we're really trying to say something else.
Okay, what are you saying?
And maybe this will help me maybe try to clarify what at least my goal is. It may not be the same as anyone else's.
Right.
So it's good on that part. So I can't speak for other people, but my interest in Fisher's theorem was, it's an interesting theorem. I wanted to understand population genetics, and I wanted to see what the theorem said and why it was criticized. It was also a good way to understand how fitness is defined in population genetics. So
right.
That what I tried to clarify in my paper is, I said this is mostly a pedagogical explanation. A reviewer did say that this was good, that we can at least contrast that the term does have different meanings. And I did look up in the dictionary the definition of fitness, and it is along the lines of what I said, that in the medical sense, someone can be physically fit. There's also the sense of someone being fit for office, for a certain office or a position. And then there's that population genetic definition. So there's definitely in the literature different conceptions of what fitness means. And I actually talked to computer scientists who work on genetic algorithms, and their notion of fit is also a little bit different. And I saw one computer scientist talk to Joe Felsenstein, and the computer scientist was kind of horrified at the evolutionary definition. He said, that's nothing of the way I conceived of it. So what I'm echoing is not unique to me. This is a complication when we use the same word to mean like 3 or 4 different things.
But it only means one thing. If you're concerned with how alleles change over time, you're only concerned with reproductive success overall. And Dr. Dan was trying to tell you that. That's all you care about if that's what you're modeling. If you're modeling something else, if you're modeling how elementary or how organisms change in size or get bigger, stronger, and faster, or become, engineering marvels, then you're talking about an entirely different thing. If you're talking about human beings, versus the rest of evolution, we're talking about an entirely different thing. It could well be the best thing for the human race to get dumber and dumber until we lose our minds entirely. I mean, that may end up being the most reproductive, successful thing, right? But so be it. That's what we're modeling. We're modeling how genes change over time. So okay. I have a real problem with coming up with Cell et al. you and the rest coming up with a problem for modeling, or pointing out that who was it, Moran or somebody comes up with a model that predicts that the population is going extinct, and that being a problem for evolution. No, that's a problem for the model. Okay, if they predict that a population is going extinct and the population does not go extinct, then there's something wrong with the model. Okay, if they predict that it's going extinct and it does, then they got the right model. So we're talking modeling.
It's expected that Will Provine said in a lecture in his debate with Phil Johnson, that he expects the human race, he said all species, life will go extinct in 2 billion years because...
Oh, probably. I mean, the Earth is going to change radically enough that we may not survive. But there's an interesting thing is you came up with, you were quoting Wagner in the beginning of this book. Do you own his book?
I don't have it handy, but I can. It's in. You can get it through. You can get the first page in Google Books.
I have it handy.
Oh, okay. Robustness in evolving systems.
Yeah.
So if you look at the chapter 1, the first page, the first 2 pages, 1 and 2. So the paragraph at the bottom goes into the second page, and that's where I quoted from it.
Right. And yeah, I saw that. And but the rest of the second page and the rest of the entire book is his thesis that even though there is genetic change and all kinds of mutations, life keeps going, robust. So he's talking about robustness. He's talking about how proteins. I wish I had some more light here. Hang on a second. I got to put glasses on, which because I have very, very low light here.
Immutable Destiny's listening to us. Oh my goodness.
Yeah. I gave him the link. I don't know what channel.
Thank you for joining us. Hopefully we won't nerd you out here.
Okay. So he's talking about the phenomena of a living cell, no matter how much genetic change there is or mutations, that the organism will either die or the cell will keep working and life will go on. And he talks about metabolite concentrations, osmotic balance, gene expression, thermoregulation, all of that. And he talks about how proteins can be modified and mutated to the tune of about 50 to 70% and still function as enzymes. And this is ubiquitous in life, that there can be all of this change, and also in populations, that we can have all of these mutations and some part of the population will still go on. And that is the point. That point where it goes on is the point where you guys really want to talk about. What you really want to talk about is whether or not a simpler protein or a simpler body plan can become a more complex body plan. That's what you really want to know. And you got all these red herrings, and this bothers me. These models that don't work or whatever, or trying to redefine fitness on us right in the middle of a debate. It's a no-no. It's Dan wasn't letting you get away with it. Did you notice that? But anyway, this whole book.
No, I was. He may not agree, but I was just trying to say this is what I was trying to say is that what has been represented as one of, like when Lenski is advertising his work, he's talking about, oh, look at all the fitness increases. And we found that from our side, we find that to be terribly misleading, that he's advertising that his experiments are showing all this fitness increase, and it's a destruction of the genome. We don't find that. We find that that's an equivocation, and it's not. It's very misleading, and we're just calling it out, and we're saying this is not a good definition. What we're trying to highlight is what they mean is not what you think. What they mean may not be what you may mean by the same word. So when Lenski kept saying, look at all these, he painted all these graphs of fitness increase. And I was just like, this can be very misleading to someone. So it may be their definition, but it's not the common sense one. And I'm just protesting and saying, you should call it reproductive success. You should not call it fitness. That's what I really was saying. And maybe that's the best thing I could say. That's what I was hammering on, is that in so many of these papers, especially Lenski's, he's talking about fitness increase, and Michael Behe will characterize it as loss of function. And I just said, okay, there's a problem here where one side is saying there's loss of function, and in the common sense notion, this is really degradation, whereas Lenski keeps promoting it as, look at all these fitness improvements. So that's why I was criticizing the usage of the word, specifically fitness. If they said this is increasing reproductive ability, I'm fine with that. But calling it fitness,
why? Why do you want to, what do you reserve the word fitness for?
the medical, because in
Darwinian?
the common usage is the idea of in the engineering sense of complexity improvement, and that was in Darwin's Origin of Species, the last paragraph of Organs of Extreme Complication and Perfection. He was likening, the way he wrote it was suggesting these fitness increases as it becomes more fit, that it's going to keep improving until you get an eye. And so that usage in Darwin is not then the same usage that Lenski is using it. But people will say, oh, look, Darwin said we have fitness increase, then Lenski proved fitness increase. It doesn't even agree with Darwin's usage. So I just think this may not be nice to say, but it seems that equivocation and obfuscation is something that evolutionary biologists would prefer, rather than having their theories actually scrutinized on its merits. They're just these smoke screens where they use other words. So that's why I was focusing on it. That's not a nice thing to say, and I'm sorry to say it.
Yeah. Okay. Yeah. Smoke screen. I agree. You guys use smoke screens all the time. I don't think that's exactly what you were saying, though, right? You were saying that we're using smoke screens, and I'm saying you are. You're confusing and complex fitness with complexity and improvement is exactly what your worldview has you doing. We don't have this worldview. Okay, it doesn't matter whether Lenski's bacteria lost a function or gained it. Lenski's putting his bacteria in a very, very limited environment. Now, but you didn't read the other 100 papers that Lenski wrote. There's about 120 of them, or about 130. And one of the things that happened to the bacteria...
For what it's worth, I'd rather spend my time studying organic chemistry with you than reading Lenski's papers. Just that I'm being very sincere about that.
Well, I would rather teach you organic chemistry than read Lenski's papers, but you guys are making us have to read them. So other things happen in Lenski's bacteria. For one thing, there was a chromosome duplication. It was a duplication without regulation, and that's how it ended up with the being able to use lactase when it couldn't before, in a different environment. And that was considered by you guys to be a loss of function. And yeah, you could argue that, but it was a duplication of a chromosome. So it gained information. I'm sorry. But there's more information when you have two chromosomes. One behaves, or two genes. I'm so sorry. Two genes.
By the way, I would agree with you on that.
Yeah.
So okay. We're cool. Okay. I'm not, as you know, every now and then I will not agree with my creationist brethren who say there's no information increase.
Right.
So we're cool on that. I just wanted to clarify that.
But the conversation is not a fair one. And you've got us off on all of these tangents trying to redefine fitness and do this and model this and talking about humans instead of talking about evolution in general. And the real thing that you want to know is how an organ develops. You want to know how a lung develops, right? You want to know how a new lumen on a stomach develops. That's the real conversation that we should be having. You want to know how a de novo protein develops. Right.
Can we? Yeah. Okay. So, since we're not agreeing, is there a way that I could say this and still try to be fair and say, okay, would it be fair for me to say the way evolutionary biologists and population geneticists define fitness is not consistent with necessarily the way it's understood by people outside of the field? Or even the way they would read Darwin's Origin of Species? Would that be a fair? Would you have an objection?
Yeah. There's a lot of misunderstandings about evolution being some sort of gain, some sort of upward direction.
So if I stop saying they need to redefine their definition of fitness, is it fair to just say, okay, this is not the way that it is said in present evolutionary literature? It's different than the way it may be understood in other fields like engineering and medicine. Because I could point to, is that fair?
Yeah.
So rather than saying, let's redefine it, if I went on the strategy and say, okay, this is the word they're using, I object to that, to them using that word, but they're going to keep using it. They're going to insist that this is the way they define it. I can't change that, but you may have a different notion for what it means by fitness. If that's fair, then maybe that's something I could say in the future. I'm just going to say,
yeah, okay, we're negotiating now. So,
well, no, well, yes, we're negotiating, but I just want to be able to say, okay, obviously you guys don't like that. My goal is to say, to at least my primary goal is to say the way that you guys may understand what fitness means is not necessarily the way it is in the literature. If I can get that far, I've achieved what I really want. Having to go and make evolutionary biologists admit that they're wrong, I think that's too much of me to ask. I think they're wrong, but I'm not going to ask that anymore.
no, we're right about evolutionary biology, and we're right about how it works in biology. But the public may get the wrong impression, and creationists most certainly have the wrong impression. You think everything was created perfectly 6,000 years ago, and it's been going downhill ever since. That's your whole worldview. That's the science that you inject. Okay, we don't do that. We have the right definition for evolutionary biology, for proving the theorem and for working it out, and for medicine, and for the future, basically. The literature that we have is correct. It's the perception of this upward direction in evolution that is perhaps misguided. Even though, since the Cambrian, we have seen more complexity in life, we may not have seen more diversity in life. It's kind of settling down into these channels, of that are limited by body plans, and we're not exactly going crazy evolution-wise anymore. And if you know what I mean, it's there's all of the, if you have this expectation that life is going to get better and better and better engineered and be faster and cooler and smarter, and you got it all wrong. That is not what evolutionary biology studies. Okay? And if that's not what our models are going to come up with. But the real conversation that you want to have, that all creationists ask, is how did life develop from, what is standing for Truth's favorite, bug to biologist or bacteria to biologist or something like that. I mean, that's what you want to know. But then, damn, you guys want us to tell you that in live chat, in that much text. And look at these books back here, and if you were to look over, I mean, we would have to tell you what's in all of those books in order to answer your question. So you're asking a very unfair question. But it's a dialogue you really want to have, and you've got us off on all these red herrings on your definition of fitness, which is completely inaccurate for evolutionary biology. So anyway, my negotiation is, or my ask of you is that you never mention Fisher or fitness ever again. And I'll be cool with that, because not until you figure out what the real impact of it is on this discussion. Okay. I mean, I think you guys are just way off the rails on this stuff.
If I could, I'm going to read something from Charles Darwin. Granted, it's old, but I do think it reflects
Who?
Charles Darwin, 1859, and it.
Darwin.
I think.
Oh, that guy. Grandpa. Yeah. Grandpa Darwin? You mean my grandpa? My great-great-great-grandpa? Okay, go ahead.
It is. This is from Origin of Species, the last paragraph of Organs of Extreme Perfection and Complication. It is scarcely possible to avoid comparing the eye with a telescope. We know that this instrument has been perfected by the long continued efforts of the highest human intellects, and we naturally infer that the eye has been formed by a somewhat analogous process. But may not this inference be presumptuous? Have we any right to assume that the creator, with the capital C, works by intellectual powers like those of man? If we must compare the eye to an optical instrument, we ought in imagination to take a thick layer of transparent tissue with spaces filled with fluid and with a nerve sensitive to light beneath, and then separate into layers of different densities and thicknesses, placed at different distances from each other, and with the surfaces of each layer slowly changing in form. Further, we must suppose that there is a power represented by natural selection or the survival of the fittest, always intently watching each slight alteration in the transparent layers and carefully preserving each, which under varied circumstances, in any way or in any degree, tends to produce a distincter image. We must suppose each new state of the instrument to be multiplied by the million, each to be preserved until a better one is produced, and then the old ones to be all destroyed. In living bodies, variation will cause the slight alterations, generation will multiply them almost infinitely, and natural selection will pick out with unerring skill each improvement. Let this process go on for millions of years, enduring each year on millions of individuals of many kinds, and may we not believe that a living optical instrument might thus be formed as superior to one of glass, as the works of the Creator with a capital C are to those of man. Yeah. And what I'm just trying to convey here is this is the popular notion of fitness back then, and it's still the popular notion of fitness outside of evolutionary biology, that we have these improvements, that there is, he even said the eye's like it's likened to a telescope, and he's saying it keeps improving and improving until it's like this beautiful optical instrument that is just as good as what God could make. That's how I read that. And he used the word fittest. And so that, to me, that does not read at all like the population genetic definition of fitness, where it's just the number of alleles. Because in the case of Gomeris minus, which is a crustacean that has lost its optical capability, natural selection picked for degrading his eyes. So, but that fits very well with the population genetic notion of fitness. It doesn't really fit with the Darwinian view expressed here, which is really more or less the common way that natural selection is understood. So it may be that it seems that creationists have just made this up, but this is even in Darwin's own conception. And if we read The Blind Watchmaker, that's how even Dawkins portrayed it. So this isn't, it may seem that maybe, I don't know, some people will say, well, that's the way creationists are defining it. I'm saying it's probably a lot broader than that. I've tried to say that's kind of the common intuition of what the way fitness or fittest is used here.
Well, that's exactly how some of it happens. I mean, that is true of a certain narrow sliver of what is going on in evolution. Okay. But you can't just focus on that one thing and say, oh, tell us how that worked. Tell us how that worked. I mean, obviously eyes evolved, I think 12 times, basically, because it was important for them to evolve and get clearer and clearer, and brains evolved with them, and visual systems. I mean, yeah, there is this upward trend in a lot of organisms for better and finer instruments to interact with the environment, but that's not the whole story. And you're not going to look at just that part of it and become obsessed with it. But you guys like to read. When was that from? 1859.
1859.
And don't you guys have another book that's actually 2,000 years old that you read from? You got to get with the more current papers, okay? Like the Bible is like a 2,000-year-old paper. This is 200-year-old paper. I'm asking you to get within, the last 5 or 10 years, and
Well, I think this you just said that this is how it evolved through a process of natural selection.
yeah,
Actually,
it did.
that's the question that is actually that was actually something that even Behe raised in Darwin's Black Box. It's assumed that natural selection was the method, was the mechanism that created the eye, and he was contesting that.
Right.
And I think that's why his interest in Lenski's experiments, where there's just so much destruction going on. If that sort of functional breakage is the thing natural selection does, it becomes a little harder to believe that it can construct, that if the dominant mode is to just trash the genome to get a beneficial mutation, it becomes hard to believe that it'll select for precursors of genes that don't even exist yet.
Yeah, that's what you choose to focus on. You choose to focus on Lenski's experiments, and Lenski's experiments are meant to show what Lenski is trying to show. Okay, he's got a limited type of solution that he keeps the same solution he keeps putting these bacteria in over and over again. If we were to create a different experiment, we may get some slightly different results. But anyway, you're focusing on that one thing, and you're focusing on if all of a sudden your ship broke up at sea, and you have just a bunch of boards, and you got a bunch of stuff, a bunch of debris, and you've got to survive. It might be a very, very good move for you to start throwing stuff overboard left and right, because right now you need a solution, right? And that's kind of what Lenski's situation has. And that happens a lot in evolution, and that is part of it. Yes, they will jettison the eyes in the cave fish, and they will lose genes here and there. But what you're not seeing is the overall long-term trend. The thing you really want to know about is how that eyeball developed. And that is the question that we should be focusing on, okay? Not all these distractions.
I think that's fair, but I don't see any experiments that would
Well, do you know how difficult?
demonstrate that these critical genes and regulatory systems actually evolved by natural selection. The only thing I see are like simulations. Like I saw one for 2019. Someone on the IEEE built a simulation that said this is how the eye could evolve. I could probably write a simulation that shows why it wouldn't evolve. I'd call it the anti-weasel. So I don't see any physical experiments. I don't see anything consistent in chemical theory that would say that this is a highly probable event.
Well, that's where you're going to find the solution, is in the chemical theory. And you're going to find it in protein folding, and you're going to find it in basically genetics and all of that. That is where the solution is going to be. You're going to be able to see the parts. Right now, the main thrust of pharmacology is to create self-creating systems, okay, evolving proteins. And they're working on evolving proteins that don't necessarily have the 22 amino acids that we're used to, okay? They're the 20 standard ones, and there's a couple of strays. But so they're working on entirely new systems, and they are making progress. And new papers are showing how these things can evolve. The thing is, you're asking human beings to reproduce in the lab the complexity of the natural world around you. And human beings, the problem I have with Christianity in general is you guys think we're a lot better than we are. We ain't that damn smart, and we ain't that big, and we're coming up and we're doing amazing things, but we are not nature. We are not the natural world. Okay, over 4 billion years. To do that in the lab in 10 years is asking quite a bit, but we are making moves. Do you understand? that you're asking to see something that happened with 10 to the 40th or 50th small changes and conditions. And you're asking that to be reproduced in the lab, where we can at best monitor 20 conditions. So we have to do it piece at a time, and we have to work out the mathematics, and we have to work out the models. And that is what we're doing. We're just not there yet. Okay. To a clear understanding. But we have spotted a few positive mutations in nature. And if we were to do what you guys do, we would go pick 100 papers and we'd show you those papers real fast and say, aha, so Blatella germanica evolved a trait. This evolved a trait. That, in fact, Blatella germanica evolved 2 of them, 2 positive mutations that changed the structure, one of a voltage-gated sodium channel, and the other one I think was an immunity to DDT or something. And these are actual mutations. They aren't epigenetic or anything else. They made a change in some protein, and that protein allowed the cockroach to survive where it couldn't before.
So what was the name of the species?
Blatella germanica, the common cockroach. Anyway, there's a sodium channel that evolved to be resistant to pyrothins, and there were 3 mutations that were involved. The first mutation made it resistant, but it also made the sodium channel not quite work as well. And then 2 other mutations came along and fixed the sodium channel so it works fine. And now we have a cockroach that you can't kill with pyrothins. So, but look that one up. And then there's there's plenty of others. You just got to search the literature. The thing is that we're not going to go out. We would have to go out in the woods and the oceans and monitor every species out there. And we don't even know how many there are. There could be like 40 million or more. And we got to monitor them, and we got to write down every positive mutation or every small step. And we can only do that for 100 years. And that's going to be our evidence. We're talking 4.5 billion years of this going on. So
I'm not ruling out. I'm just going to speak at a purely personal level. It just doesn't sound believable to me.
I know it doesn't, but it does to me.
It sounds to me like this is a faith statement that nature can do it given enough time and all the complexities of nature. And so it's like, I think it's fair to say that no one is going to account for every molecule in the history of the universe,
of life.
That probably would be what it would take to settle this, but at that point we'd be God. So I think this is an issue of what statement each individual finds more believable. I'm not gonna fault someone terribly if they just have a different view. I'm just kind of the person. I don't like telling people how to live their lives or what they believe.
Right.
I'll say I disagree. This is why I vehemently disagree, and this is why it's not for me. And that's about it. Because when I start telling people how they ought to live their lives, it's like me telling them it's really not my business. It's their life. It's not mine.
Yeah.
And I respect. They're just boundaries. So the most that I could say is that I don't find it believable. I'm happy to articulate why I don't, and that's about all I could do.
Well, I'm an evolutionist, and evolution is my religion, and I have faith in nature and complexity. And
there's an interesting book, by the way.
Here's what I do not believe in. I do not believe that the Earth was created 6,000 years ago suddenly, and life was created suddenly, and then 1,400 years later, it cracked open like an egg, and a small wooden boat built by primitives floated around on these tsunamis that were 700 feet high for a year and landed and created all of this. I don't believe that. I don't find that believable. What I do find believable is that proteins have domains that are like Legos, and they can break and reform and do different things, and that complexity can create life. So that is my religion. But I don't believe in your religion. I think your religion requires some pretty fantastic stuff. You got to admit that flood story is a little hard to buy.
And no, and I respect that.
Okay.
So I respect that, and I've often said there'd be more people that would be friendly to creation if God just worked miracles in their personal life.
Yeah.
And
Like,
that's
all I ask is heat my coffee up right
so.
now.
But just as an aside, actually, my professor worked on my professor of bioinformatics. He was the co-author of the paper, and I'll type it in. Domain promiscuity. So what you were talking about, the domains relocating. Let me see, domain.
Promiscuity?
Make sure I get the domain promiscuity. In eukaryotes, let me make sure I get the title right. Evolution of protein. I'll type it in. Evolution of domain promiscuity in. Let's see what and I'll see if it'll let me type the link here. In eukaryotes.
I think I actually have that paper somewhere behind me here.
The third author was my professor.
Okay, I will look that up. But, it's a matter of, what we believe in. And what worries me about you, Sal, is that you're only stopping at the top of the papers, the part that say there's a problem for evolution. You're not going down into the chemistry and into the deep, deep mathematical complexity of how molecules actually form and work, that sort of thing. You're stopping at the point that verifies your belief, and you're not going further. You're not looking further.
Well, that may be a fair criticism, but I'll tell you that the thing that reinforces it is I happen to know the creationists that are at research institutions. They're kind of closet, but they're very successful chemists. And
James Tour.
Not as high as James Tour, but I know people in academia, both in secular academia, and some of them have come out of the closet. I mean, Change Tan is one. I've mentioned her. Rob Stadler's another, but he's not a chemist. But I do know chemists personally, and who are cancer researchers. They sit on peer-reviewed committees, and they share my viewpoint. These are the younger generation of researchers. So I'm just trying to convey to you that.
But they're Christians, right? And they're creationists?
Yeah. Some of them, a good number of them were not always. So that was a big.
Show me an atheist that believes that studies the science and believes that. And I don't have that worldview to rescue me, right? To stop my studies. So I have to keep going deeper and deeper and deeper and trying to find exactly how this marvel occurred. Okay. Because I don't have a stopping point. I have to keep learning and putting it together. It's like, okay, so that's how that happened. And that was the journey that I made was from, I had a point where evolution seemed like way too magical. Okay. But I had no choice but to look further. So I got some books on embryology, and that was when it all changed for me. It was like, I never didn't not believe in my religion of evolutionism, but when I read embryology and morphology and the amount of, and how genetics affected that was the point where I could start to see how the mechanism worked. And when you see how the mechanism works, you believe it. If somebody shows you a magic trick, you might think, oh my God, this guy is really doing magic, until he explains the trick to you and you see how it works. like Answers in Genesis today, did a little video where they had a bottle of water with a little uh, penta something or another, and somebody would tell it, okay, go up, and it went up, go down, go halfway, and it kept doing it. And it turned out he was squeezing the bottle, and that was making it go up and down with the pressure, right? And I was looking at it, it's like, how are they doing that? That looks like magic. But then he explained it, it was just changing the pressure in the bottle. It would change the pressure in the little air bubble that was in the thing, and it would float up and down, that sort of thing. So, I mean, before you know how the magic works, it looks like magic. And I'm saying that you have to not stop. You have to look all the way down to the bottom of the magic barrel and figure out what the trick is. And that is the problem I have with the belief that the Earth is 6,000 years old. You're not going to look at the science until you get rid of that idea, until you at least entertain the possibility that you are wrong and that God created this universe in a different manner. You do not have to give up your religion. You just have to give up your science denial.
Well, I believed in the old Earth.
Yeah, and then something went wrong, obviously. What was that?
I started studying physics.
You didn't go far enough.
Actually, when I was in grad school and I heard, so one of my professors, James Treffel, I'll write his name, James Treffel. I'm sorry. I shouldn't have something in my mouth when I'm talking to you. I apologize, Mike. James Treffel. I know what this is. It's like a pacifier. It makes me feel, when you put the pacifier in the baby's mouth and it just kind of shuts. If
I weren't so afraid of starting to smoke again, I would have a cigarette around. But I'm so afraid of cigarettes that.
Yeah. I hope I'm not being a bad influence on you, Mike.
I'm 9 years in recovery on cigarettes, and that's from 2 packs a day. So
5 reasons galaxies. He was my professor, quantum mechanics, when I was at George Mason. And he's not an ID proponent. He believes in the Big Bang, but he has some reservations. And he wrote the chapter in the book, The Dark Side of the Universe, the 5 reasons galaxies can't exist. And that was beginning, just like wherever I turned, that there were always these little complications. And then I went to graduate school. And then one professor said, just between you and me, I shall not identify who he is. I don't believe in dark matter. And then when I was studying astrophysics and cosmology, especially cosmology, and I heard of the inflation model. So at that time I was like, okay, I think God created life. Probably the universe is old, but I think life is relatively recent. I wasn't a full up young earth creationist at the time. And I began to have doubts. So you're asking what went wrong. It's like, well, I just started to study more, and my ears were just attuned to whenever something, a book or something in the literature said this is an outstanding problem. I was like, yeah, this is pretty tough. What I understand of physics, this is a tough problem. And there was a book, I'll put it down, Solar System Evolution. I actually bought the book by Stuart Ross Taylor. At the time, I was an older creationist. And I said, well, let's try not to talk about the whole universe. How about the solar system? So I got this book, Solar System Evolution by Stuart Ross Taylor. It was supposed to fight creationism, but by the time I finished reading it, I said, oh my goodness, he couldn't have written a better creationist book, because at the end of almost every chapter, he was saying, this is a severe, outstanding problem in physics. I'm just like, yeah, I just finished my undergrad in mathematics with a minor in physics, and I studied classical mechanics and then orbital mechanics. I said, everything he said in saying this is a problem, I totally see it too. I said, this is not, God couldn't have made a solar system more. He made it in a way that made it really hard to interpret that it just evolved from a nebula. And that was the beginning of my doubts. And then when I started studying cosmology, they talked about inflation, where galaxy-sized quantities of matter are being pushed around at millions of times the speed of light. And this also led to variable speed of light theories. I said, anything's possible now. And that was the beginning of, so I'm not like, it's not like I haven't gone through at least some modest process while starting out as an evolutionist. And the more that I had learned, the less I found things believable. So maybe I'll admit, because I am a Christian, I'm probably a lot more biased than an atheist. But, and my own professor, who I think I don't know, he hasn't talked about his religious views, James Treffel, when he talked about the 5 reasons galaxies can't exist, I said, yeah, these are problems that are, not only are they unsolved, but there's evidence that the solution he proposed with dark matter is just wrong. So I know it may be easy to just say, you look at other people like someone who's hadn't had any education and he's just raised up in the church, and you think he's just being a science denier. I don't think that's the case with me.
Well, you come to a full stop at the end of the chapter when it said these are a problem for physics. Any good scientist worth his salt will always tell you what the problem is and what we don't know. And I don't come to a full stop. I go a little bit further and I figure out, okay, if I were to be a physicist, then I would work on those problems. And when you guys come up with a problem for evolution, I get on Google, I get my books, I get on Amazon, and I start solving the damn problem.
And I respect that, but in my view, I said that maybe God did it. Probably is the solution. Physics has succeeded. To me, physics and science has succeeded. And Richard Dawkins said, the existence of God is probably the greatest scientific question. And I'm just like, well, that's kind of cute. Well, then if we find evidence of a miracle, then science has succeeded. Now, he never really, I don't think he has a very coherent viewpoint, but the creationists were kind of thrilled when he said that.
Yeah. Well, if we find evidence of a miracle, I would be thrilled to investigate that. I just haven't seen any so far. So I keep looking at these other sources. The thing is, you gotta quit coming to a full stop. And, a lot of these papers, Brady and Olson here, these guys that you sent me, you were making, no, bear with me here so I can explain this.
Sure.
You were commenting on SFT and on John Maddox's channel. It's 2 words, Maddox. You were commenting on his channel that it was a good thing that God made mice and chimpanzees so that we did not have to do testing on human beings. Okay. Well, it's a good thing that God made philosophers of science because we could do tests on them. Okay.
Oh man.
Because that's all they're good for.
Oh, man. You know what my nickname for you?
Huh?
You know what my nickname for you, because you were in the Iron Range? I call you Iron Mike.
Oh,
you're a tough guy, man.
You're not the first one that's picked that name for me. So
Iron Mike.
I hear that a lot from the Iron Range. That is a $96 book. Oh, but they have a used one for $6. The Solar System Evolution. So
I bought it for $100 way back in 2005.
Yeah. I just paid $220 for a new version of Genetic Analysis by I forget who it is, Sanders, I think, or something. And I got a really good one for you right here. You're gonna love this. And Immutable is so mad at me because I won't buy him one. But look at that. Can you see that? The Essentials of Glycobiology.
Dang.
Yeah.
That's good stuff, man.
A thick one. And so we're getting ready for our conversation. I'm also getting my copy of The World of Carbon from my great niece who lives on the Iron Range. She's supposed to bring it to me because I want to use some material from that to put together a slightly better quality discussion with you on organic chemistry. And then we're going to try to get into sugars, but I've got to do some homework before that. And Immutable has to do some homework too. But that'll be the next step, is to get into carbohydrates and glycans, which that book is about. But that's an incredible little book. Little book. If I dropped it on my foot, I would break my foot.
Well, as I said, it's clear to me there are definitely things we're not going to agree on, and I think it's fair to say that I'll come to a full stop and quit on a naturalistic explanation much faster than you. I mean, if I could ask this, would there be a point you would ever stop searching for a naturalistic explanation? Naturalistic in terms of our being able to extrapolate accepted laws or anything we discover in the lab.
Well, if we found out that God did it, if we had some really good proof that God did it, I would want to know, when did God did it and how did God do it? And what would it be like if I was there when God was doing it? Like when he created an elephant, what happened to the air that the elephant displaced? I would want to measure that and find out if the air took off at the speed of light, or if the elephant grew from an embryo over a period of 2 hours. How did God do it? So that would be.
Well, I mean, no, this is actually a very important point, and I've tried to say, well, it's thoroughly understandable. We'll only believe in things that we understand. Like, that's just human nature. Is there a point where we would be willing to accept an explanation that would probably be out of our reach to understand? And that's, yeah. So I'm a lot quicker to say I'm willing to accept, like a little child, that something happened which I will never explain in terms of anything that I could understand. And that's a little harder than, especially because I am in scientific disciplines. It's like, I will accept explanations on the whole that I can understand, that I can reproduce, that I can control on demand. That's just, and I totally get that, because when we build something and we want to have faith that it's going to work, it's great that we can build it and we understand all the parts. Maybe not one person could actually understand how an entire airplane works, but he has a staff of people, and collectively they understand how the airplane works, and they'll have faith. So I totally get that. So the thing with miracles is, if something happens that we can't understand, and presumably God can do things that are way beyond our understanding or capability, how much would it take to believe in something that to entrust an explanation and say, this is something I'll never understand? Some of us are willing to accept that. A lot of people that are professional scientists won't, and I totally get that.
Yeah, the only time that's ever happened to me is with women about 20 years ago. It's like, I'll never get it, so I quit. But other than that, I am an infinite regress in how and why. How. Like, my dad was a diesel mechanic and also an iron miner. He worked in the iron mines. And he had the theory when I was 16 years old that you cannot fix an automatic transmission. No one can do it except for a factory. You cannot fix automatic transmissions. You can fix manual ones. And so I went to the library and I got books on automatic transmissions. I took a course. My transmission broke on my 62 Chevy. And my old man was like sitting back saying, you can't learn that out of a book, And so I overhauled my transmission. The drive went out on it, so it just didn't, or the reverse went out on it, so it didn't go in reverse. So I repaired it, got it all together. My old man was sitting there, got in the car, started it up, backed up, reverse worked. My father's, was frowning. I put it in drive. It wouldn't work. It wouldn't go forward. He got a big smile on his face, like, see, you can't do it with book learning. You can't do it. So 4 hours later, I called him back, and it was going both ways. I took it apart. I got a ring wrong. But anyway, all he did was swear under his breath and walk out of the garage, and that was the last I saw from him.
See, that's your drive. That's your drive to learn things, and that's what drives science and progress. And so I totally respect that.
Yeah,
I totally respect that.
Okay, I think we're
all right. I'm going to end the broadcast.
As I remember, you agreed never to pick on fitness or Fisher Wright again, and we're good.
I don't think I agreed to that, but
we'll play it. We'll play the tape back. So we'll play it back. Anyway.
All righty.
Okay. I have to.
I'll chat with you after the broadcast. I'm just going to end it.
Yeah.
So
next time.
Thanks to all our viewers, and that would be Immutable Destiny, and he may be the only one, but thank you.
Yeah. Well, nobody had the link.